So, dear students, it's my pleasure to introduce this self-learning topic on functional units of a computer. So now I would like to share my screen. So today's self-learning topic for discussion is functional units of a computer. So lecture objectives are what are the different functional units of a computer. So there are two important terms that we have to understand what is the difference between a computer architecture and a computer organization. That is the CA computer architecture. What is meant by computer architecture and what is meant by computer organization. So, architecture is concerned with how the hardware components are connected together to form a computer system. That is what is meant by architecture. So, that is how hardware components are getting connected to form a computer system. Then coming to this computer organization, it is concerned with the structure and the behavior of a computer system as seen by the user. So the functional units of a computer are basically this IO devices, so input output devices, and memory, and arithmetic and logic unit, which we are calling it as ALU, and then control unit. And these ALU and control unit together we will call it as a processor. And these memory and the processor and IO devices are get connected through a network within the system. That is what we are calling it as interconnection network. So what information that is handled by the computer? Generally, the computer will handles the instructions, which are also called it as machine instructions. And here, these machine instructions generally we will use to transfer the data or information within a computer between different components of a computer and its IO devices. And these instructions also specify what type of arithmetic and logic operations to be performed. And if you are writing a set of instructions, that is a group of instructions, if you are writing, then it is called it as a program. So a program is written to solve a particular task. And the programs, whatever we developed, those programs are going to be stored in main memory. When that programs we have to execute, then that particular programs are brought into the main memory. So what that processor will does is that processor will fetches the program instructions from the memory one after another and performs the desired operation. So that is what the processor will does. Then another important term is data. So data are nothing but it may be numbers or characters, so which are used as the operands for the instructions. So data is also be stored in the memory. So we have the input unit. So computer will always accept the coded information through the input unit. So that is nothing but we are giving the instructions to the computer. So the input unit is nothing but a keyboard. Different types of input devices we will use: keyboard, touchpad, and mouse, and then joystick, and then trackball. These are the different types of input devices. Microphones. When we are trying to input audio, we are making use of microphones as input device. So these are the different types of input devices. When we want to input video, we will make use of cameras. We will use that. And then coming to this memory unit, so the function of the memory unit is to store the data and programs. So just now we have seen that a program is nothing but set of instructions, whatever we have stored within the memory to solve a particular task. That is what we are calling it as a program. So there are two classes of storage, generally called it as primary storage and secondary storage. So the primary storage is nothing but the main memory which we are calling it as, and the secondary storage is we have different types of secondary storages we have. So primary memory is also called it as main memory, which is a fast memory that operates at electronic speed. Programs must be stored in this memory while they are being executed. So memory is consisting of large number of semiconductor storage cells. So we can view that a memory is the main memory can be capable of storing binary information, and it is consisting of a semiconductor storage cells, and each cell is capable of storing one bit of information, and these semiconductor storage cells are grouped together, which we are calling it as a word memory word we are calling it as. Why? Because we are grouping, because to handle that words it becomes easy for us. So one word can be stored or retrieved in one basic operation. So that means when we want to perform storage or retrieval from the main memory through the instruction, so we are performing these operations in terms of words only. So that is what it becomes easy for us. So the number of bits in each word is referred to as the word length. So how many bits we are taking, so in a particular word, that becomes it as a word length of a computer. Generally it is a 16 bit. If you are taking 16 bits, so it is a 16 bit computer. If you are using 32 bit or 64 bits, so nowadays we are making use of 64 bit as a word length, we are using that. So a distinct address is associated with each word location in the main memory. So a memory in which any location can be accessed in a short and fixed amount of time after specifying its address is called it as a random access memory. So the time required to access one word is called it as memory access time. So it is typically ranges from few nanoseconds to about 100 nanoseconds for the current RAM units. So it is the access time which is required for accessing a word from main memory depends upon this nanoseconds to 100 nanoseconds. So another important memory which is very close to main memory unit is called it as a cache memory. So it is a small faster RAM unit, okay, so which is more fast accessible, and it is used for storing the program parts which are more frequently accessible. So currently being executed program parts and currently being executed data is to be stored in the cache memory. So the cache is tightly coupled with the processor, and is usually contained on the same IC chip. So when the program starts its execution, so initially the cache is kept empty and all program instructions and any required data are stored in the main memory. So as the execution is continuing, so the instructions are fetched into the main memory by the processor chip and a copy of each is placed in the cache. So when the execution of instruction requires data located in the main memory, the data are fetched and copied and also placed in the cache memory. Suppose a number of instructions are executed repeatedly as happens in a program loop. So these instructions are available in the cache memory and they are fetched quickly during the period of repeated use. Then next coming to this another important type of memory which we are calling it as a secondary storage. So even the primary memory is essential in any computer system. So it tends to be expensive and does not retain information when the power is turned off. So when we want to store the information for future purpose, we will make use of this secondary storage. So which is a less expensive permanent storage and which is used for storing of large amounts of data we can store in the secondary storage. So the access time for secondary storages are very large than the primary memory. So where in primary memory it is a few nanoseconds to 100 nanoseconds. This is the access time for primary memory. But when we are coming to the secondary storage, so it takes more time than this. So a wide selection of secondary storage devices are available nowadays. So including magnetic disks, optical disks, which we are calling it as DVDs and CDs, and flash memory devices, memory cards, etc. So nowadays we are provided different types of secondary storage devices. Then coming to the next important component in the computers is arithmetic and logic unit. So the name itself indicates that the purpose of this unit is to perform arithmetic operations as well as logical operations. Okay, so any arithmetic or logic operations such as addition, subtraction, multiplication, division, and then logic operations are nothing but comparison. So those we can perform by making use of this ALU, arithmetic logic unit. Then coming to this output unit, so the main function of this output unit is to display the results to the end user or to the outside world. So generally the most important output device which we are making use of is printers and then graphic displays and then fax, speakers which is used for generating the audio as an output, and then we are making use of screens which are nothing but for displaying of this output information. Next another important component is a control unit. So the memory unit and ALU unit and IO unit which is connected with all these units are getting connected through a network and these are monitored and controlled by this control unit. So the operation of these units, memory or arithmetic logic unit or IO units, the operations of these units must be coordinated and controlled by this control unit. So the operation of a computer can be summarized as follows. So the computer accepts the information in the form of programs and data through an input unit and stores it in the memory. So the information stored in the memory is fetched under program control into an arithmetic and logic unit where it is processed. Processed information leaves the computer through an output unit so that it will be displayed onto the screen. So all these activities in the computer are directed by this control unit. So that is nothing but what we are doing here. We are storing the programs and data within the memory. So the processor will fetch that programs which are stored in the memory and performs the required arithmetic and logic operations, and that processed data or information which is generated as an output, and it will be displayed onto the output device. So all these activities will be coordinated by this control unit. So this is what the different functional units of a computer. So this is the outcome of this today's lecture. So after completion of this today's session, so you must be able to know what are the different functional components of a computer. So thank you, students. Thank you for listening to this lecture. I hope you enjoyed this session.